Have you ever seen a manufacturing plant where a template is used to create multiple objects? Sounds confusing? Well then, you need to know about classes and objects in Java. In this chapter, we'll look at classes, objects, and related topics such as stack memory, heap memory, the static keyword, what is passed by value and passed by reference, and many more. It's going to be an overwhelming amount of knowledge. Stay tuned.
In this chapter, we're going to talk about classes and objects. And in this particular video, we're going to get a glimpse of what classes are and what objects are. Now, I have a confusion between classes and objects as to where to start from. Should I start explaining about classes or should I start explaining about objects? But I thought it would be better to start with neither. Instead, I would start with methods. Now, if you go take a look at other tutorials, they may start by giving the definitions of classes and objects, which I feel at this point of time you may not be able to understand. My way of teaching is different. I'm going to give you a real-time example, and from that you can easily make out definitions. That makes more sense. Anyway, let's get started. Let's talk about methods. Let's say we have an e-commerce website, something like eBay or Amazon, that was written using Java. And let's say our code, our source code constitute of 2000 lines of code. It would probably be exceeding 1 million lines of code, but just for the sake of explanation, let's assume so. And the entire code is under one block. Now within this code, we might have a set of instructions spanning across 10 to 20 lines that does a particular task. For example, add product to the cart. And there could be another set of instructions that does delete product from the cart. And there could be instructions on applying the coupon, or something like make payment, etc. Now we have a problem here. We are lacking code readability. Let's say you wanted to perform the same operation, add, at later point of time. Then you're going to write this set of instructions, 10-20 lines, again somewhere over here. That's going to increase the complexity and reduce the readability. The new programmer who will take a look at your program will definitely curse you. So what is the solution? We're going to create methods. If you are aware of functions in other programming languages, that's nothing but methods in Java. So what we essentially do is we're going to take out this set of instructions that does a particular task, separate it out, put it inside another block, and we're going to name this block something like addition or something like that. And whenever we need to execute this set of instructions, instead of writing all those 10 lines, we're just going to simply call this block of statements using this name, addition. Similarly, next time you'll have to do the same set of operations, then you're going to simply call this block using this name again. That will reduce 2000 lines of code into 50 lines. This will increase the readability. Also, the code is more organized. And this block of statements that I'm talking about is nothing but methods in Java. Now let's try to form a definition of a method. A method is nothing but a set of instructions in a block that does a particular task. And that block of statements will have a name tag to it so that we can use it to execute those block of statements. Let's go to our workbench and see how this works. Open the file named classes and objects under the project classes and objects. Now I'm going to simply copy paste the code from switch statement example that we talked about earlier. I'm just going to copy the code inside this block, the main block. I do Control C and paste it over here inside this main block. I'm going to save it. Now let's say we want to separate this statement out and put this inside another block. The first thing is to take this statement. This could be one or more statements, but in our example is just one statement. We're just going to do Control X, and we're going to take that statement out of this block like this. Now what we're going to do is we're going to call this statement or statements from here. How do you do that? We need to give the statement or the set of statements a name. So for that we need to create another block using curly braces, and we're going to give it a name, something like addition. Now this block of statements is not aware of these two variables a and b, because a and b are initialized over here in a different block. So the scope of this variable are within this block. So what we're going to do is we're going to give parenthesis, something like that, and we're going to send these two variables from here. So first of all, let's put this over here and send a comma b, and since this is a statement by itself, we're going to end with a semicolon. We have sent a and b here, but we're not receiving it here. How do we do that? We're going to give the type of the variable int that we're expecting, int a and int b. Now this block of statements will be aware of these two variables a and b. We have another problem here. What's that? Whenever we execute a certain block of instructions, we're going to expect something out of it. Sometimes we don't. Here we're just doing system.out.println a plus b, and we're printing it. In this case, there is nothing that we want to give back to the block where we're calling this method from. So what we do is we say void, which means I'm not sending anything from this block of statements or from this method addition. In case if you want to send something, then you might want to use the keyword called return. We'll talk about it in detail at a later point of time. So for now, this is it. We have a proper method declared or defined, whatever you call it. There's one little twist here. Since this is a static block, we didn't talk about static block, but we will in a while. This has to be static. We'll talk about static keyword later point of time, but this is it. Now this will essentially does the same thing what we're doing here, but in this example we just have one instruction. Let's say these are 10 or 20 lines of code, then that would make perfect sense to use methods instead of writing the code over here. If you run this program, it's going to yield the same result. Let me save your time by not running it. Great. Now we understood what method is. It's essentially a block of statements that does a particular task, and we're going to give that block of statements a particular name so that using that name we can execute that block of statements anywhere in the program. So next time we want to execute this set of statements, we're just going to do copy paste of this, Control C, and maybe we're going to put it over here. By the way, that's illegal to put it over here. Let's save the file. Great. Let's go back to our whiteboard. Now obviously we don't want the entire code to be under one file. Think about Amazon or eBay, where the source code would be in millions of lines of code. How could it be possible to manage the code if it is under one single file? Probably the entire code is split across multiple files, class files. So what we're going to do is we're going to create multiple files, essentially class files in Java. Say we're going to have a class file called product that has the methods that are related to product. For example, add product, remove product. and we're going to have another class that's going to do checkout. And this may constitute methods like apply coupon or maybe make payment. Now let's understand this in our example. So what we'll do now is we're going to take this method out of here to a different file. So for that we need to create another class file. So let's do Control-C and Control-V. That will create a clone of this class. We're going to name this class as Maths class. I'm going to click Refactor, and we're going to get rid of this entire code in here. In fact, we're going to get rid of this entire block altogether. We don't need main method here. For the entire application, we'll be needing only one single main method. We'll talk about it later. But now let's move it over here first. I'm going to do Ctrl-X, cut it from there and paste it over here. We definitely will have an error here because the method is no longer existing here. So how do we call this method residing in another class? This is how we're going to do. I'm going to say somewhere over here, math obj stands for object, and we're going to create a new object using the keyword called new, and then again maths, typo error there. So what did we just do? We created an object. Ladies and gentlemen, welcome to object-oriented programming language. This is what is object. Of course, we're going to talk about it in detail in a while. Now using that object, we can call that method by doing object.addition. Let's continue in our next video. Let's continue. Not sure if you have observed or not, but we've been using classes, methods, and objects already. What does this out.println mean? Out is nothing but an instance of a class, and we're just trying to call a method inside that class. What this method does is just going to have some instructions that will print this statement on the console. And the main that we've been talking about is nothing but a method with some arguments. We're going to talk about this statement pretty soon. And in here, classes and objects is nothing but a class. So knowingly or unknowingly, we've been using all these throughout our examples. Now these variables in here doesn't necessarily have to be inside this method. It can also be inside a class within this block. Let's try to do the same thing in our maths class. So we can have int x equals 10. We can have int y equals 20. And you can have a method. By the way, we don't need to have static in here. Should have fixed it in our previous example. See, we don't have any error here. That means we're good. I'm going to do Ctrl-S, save. We're going to create another method. Void, let's do product of x and y. We're just going to simply copy paste this line and do it's x multiplied by y. Let's do Alt Shift and F. Alt Shift and F, that will indent the code. That looks better. Now using this object, you can also invoke this method. Now note that we don't have any arguments in here. We'll talk about syntax of methods pretty soon. in our next video maybe. But yes, this is it. Let's try to understand a little bit more about classes and objects. Why is this called an object? This is somewhat similar to real-world objects. If you're talking about real-world objects, it has two things. One is the state and the behavior. Let's think about a dog. A dog will have a state of height. It can have a state of breed, or it can have a state of color. Coming to its behavior, a dog can walk, or maybe running, or maybe sleeping, etc. Let's take another example. Let's talk about a car. A car will have a state of brand name. A car will have a state of number of seats available. Coming to its behavior, start the car, stop the car, or change the gears, etc. An object in programming world does have a state and a behavior. When I'm talking about a state, those are nothing but the fields that we initialize or declare here. Coming to the object's behavior, the methods that we write here are nothing but an object's behavior. We can have multiple objects from a single class. Let me explain you in detailed fashion. Let's go to whiteboard. Let's say you have a land of 10 acres. Now what you want to do is you want to construct 100 houses. All these 100 houses are constructed based on one single design. This design is nothing but a class, and all these objects that use this design are nothing but instances of this class or objects. So now let's try to form definition of a class and an object. A class is nothing but a blueprint of an object, or a template using which you will manufacture multiple objects. Whereas an object is an instance of a class. It will have the state of number of bedrooms available, or the color of the house. It can have a behavior of add tenants, remove tenants, check mailbox, etc. Let's go back to our workbench. Just as in our example, we created multiple objects, we can also create multiple objects of math class. For example, we can say object 1. So essentially what we did here is we have two objects but are identical. Objects doesn't necessarily have to be identical. Let me explain you what I mean. Again, let's go back to our whiteboard. Although all these houses are based out of one single design, that doesn't mean all these houses should stay identical. They can vary in terms of color, number of bedrooms available, etc. So when we're trying to create an object, we'll also set its state. And we'll give the values like number of bedrooms available or the color of the house, etc. Going back to our workbench. Sorry about the frequent switching. Now let's get rid of this. So how do we set the state of an object? We used constructors. Let's talk about it a little bit. A constructor will have the similar syntax as to that of methods. We haven't talked about the syntax of methods and constructors. We will in our next video. But constructor will have the same name as to that of the class name in which it is residing. So we'll simply say maths, and then that's it. We have a constructor here. And instead of setting these values in here, we're just going to get rid of all these initializations, and instead we're going to send parameters to this constructor. We're going to say int, say d, comma int b. All right, let's say k. X equals d, y equals. Now this should bring us an error here. So what's going on? Whenever we create an object, it will definitely call the constructor first. If you don't create any constructor, by default a default constructor will be considered. What's a default constructor? A constructor without any parameters and without any content inside it is nothing but a default constructor. So what is the purpose of it? Let's say you have a class called dog, then let's say you have a field called height. If you don't set anything, constructor will do that for you. It will give the initial state of the dog. It will set the default value. It will set the value to be 0 if it is an integer type. Now since you gave your own constructor with parameters, the default constructor will no longer be considered. You'll have to write another constructor which does not have any parameter. If you don't write one, then at least send some parameters in here with object. So we'll send 10 and 40. So the moment this statement gets executed, we'll set the state of this object as x equals 10 and y equals 40. So now think about it in this way. Let's say this is a house class. We can set the number of bedrooms and the color of the house using a constructor. And throughout our program, we'll use those particular fields. So what do I mean by that? Had this been a class called house, then you can have an object, a house object with say number of bedrooms 3, and you can have color as red. We can have another object 2 of house with number of bedrooms as 2 and color as green, something of that sort. You can have as many objects, you can create or manufacture as many objects as you can. So that's what is the job of a constructor. Now I hope it makes sense. You can run the program, you can play with this program in whatever way you want. You can also say object dot product to print the statement. Alright, see you in my next video. Let's talk about methods and constructors a little bit. For the sake of explanation, I have created another class, and that has the code exactly what we need. I have two variables and an object of class maths, and using that object we'll be able to execute this method addition, which is residing in the maths class. This essentially means we're triggering the behavior of that object. Now in here we're sending two parameters to this method. This is not mandatory. You can also get rid of this. You can also get rid of it. Let's save the file. By the way, I guess we have errors here because these two parameters are no longer available. Instead, what I'm going to do, instead of finding the addition of a and b, I'm going to find the addition of x and y. I'm going to save the file. Now this is going to bring an error here because in this method we're not receiving anything, so we should not send anything. We'll get rid of this. I'll save the file and let's try to run the program. What is the result expected? While creating the object, we're also calling the constructor in here, and we're setting these values just as I explained in my previous video. So the result that I'm expecting is 50. Let's try to run this program. By the way, I guess we have an error here. Let's get rid of this. I don't know what it is. Okay, we've changed the method here so it would impact here as well. Now take a note of this. Changing anything in here will actually impact everywhere else. Now we're going to talk about that problem and its solution pretty soon when we talk about access specifiers. But for now, let's make the change. Now we run this program, run file. This will give us 50. Well, hopefully. No, it will. 50. Great. Let's expand this. So we can also have methods without arguments at all. Methods can also have a return type. What do I mean by that? I don't want to print this here. Instead, what I want to do, I would like to return the result. And when we return something from this method, we're also going to say what we're returning, which type of data we're sending back to the calling method. In this case, its integer. So I'm going to say int. And if we're sending something, we also receive it over here. So we're going to have another variable, maybe int c. Actually, we're going to get rid of this a and b because we're not using them. So I'm going to say int a equals 0, and I'm going to assign a value to that a. What's that value would be? Whatever I'm returning from this method. So we're calling this method object.addition here, and whatever is being returned from here, we're going to receive it, and I'd like to print it. System.out.println. Let's print it. Let's run the program and you would get the same result. There you go. Now let's take a look at the syntax of methods and constructors. A method will have the following syntax. It will have an access modifier, which we'll talk about at a later point of time, so ignore for now. We're going to have a return type, which I have just looked at. A return type can be of any type. It could be a primitive data type or a user-defined data type. We'll talk about user-defined data type pretty soon. We're going to give a name to that method, and we can have no or any number of parameters. And within this block, we'll have some code with optional return statement. If the return type is of void, then probably we don't need to return anything. If this is of type int, then probably we should return the integer from this method. Now coming to constructors, the syntax of a constructor is no different from method, except for a constructor there won't be any return type at all. It will have access modifier, it will have a name, and the name supposed to be and should be exactly the same name as to that of the class in which it is residing, including the case. There won't be any return statement because we won't have any return type here. So essentially this is the syntax of a constructor. Okay, now let's go back to code and talk about one important thing. You can think of math as a user-defined data type, just as int. Int is a primitive data type, maths is a user-defined data type. Now when we have this statement defined, we can literally use this object just as any other data type, like int. So that also means we can also return an object from this method. This could be of any data type, including user-defined data type. The maths in here is just a user-defined data type, and you can use the same way you use a primitive data type like int. Alright, this might sound a little confusing. I'm going to clarify it in next 2-3 videos. See you in my next video. I'm not sure if you're aware of this, but we do have a psychology tracking system. Each and every one of our video will go through this system to make sure that the viewer is able to understand the concepts clearly. If the rating is below 9 out of 10, then that means the explanation needs to be improved. The rating that I got for my previous 2 videos is 7.5. That means some of you must be having some kind of confusion around this objects and classes. So this particular video I'll try my best to bring clarity on it, and even in my next video we're going to get into the technicalities of it, and you will definitely better understand the concept. Okay, now take a minute or maybe pause the video and try to figure out the output of this program. Okay, let's move on. We have created an object 1 and we're calling its constructor with the values 10 and 40, This is a parameterized constructor, and these two parameters we're just simply assigning to these variables x and y. And when we execute the statement, it's object1, which is this, dot addition will invoke this, and it will find the addition of x and y. So what's the expected output here? It's 50. Now coming to second object, we're creating a new object altogether with different value, 20 and 20. So the values of x and y would be 20 and 20 for this particular instance. So this is one story, this is a different story. I'll bring you clarity on this in my next video, where we get into some technicalities and see how memory allocation is done. Remember our example on houses? Using one single template, we create multiple houses. In the similar fashion, we're using single class to create multiple objects. We have two objects in here, and each with a different state, just as I have explained in that example of houses. You may want to revisit that video if you wanted to check that out. But in here, for object 2, we have two different values, 20, 20, and the result of addition would be 40 for this statement. We have object 3, for which we're assigning object 1. So object 3 will constitute the same values 10 and 40. This is somewhat more or less similar to int x equals 10, int y equals x. This is somewhat similar. Remember I said this is like a user-defined data type and this is primitive data type, and you can use this user-defined data type just as primitive type, and hence even assigning is possible because object 1 and object 3 are of same type, maths. So what's the value? What is the result of this instruction? It would again be 50. Object 4, we're assigning object 3, which in turn is being assigned to object 1. So the result of object 4 should be same as well. Coming to object 5, we have, instead of assigning the values, I'm just trying to take the values from the object 1. When we created this object, we have actually assigned the value 10 to the variable x. So this would be 10 and this would be 40. The result of this statement would be 50 as well. Let's try to run the program. See, just as we expected. See you in my next video. In this video, I'm going to talk about stack memory and heap memory. Remember this toy from your childhood? How do you take out the yellow ring from this? You'll first take out the blue ring and then you'll take out the green ring. Only then will you be able to pull the yellow ring out. This is sort of like a last in, first out, which means the last one that comes in is the first one to go out. So this is called stack approach, and it follow last in first out approach, LIFO. Java follows the similar methodology to allocate memory while we run the program. So we'll have a stack and it will have sections in it. Each of this section will be dedicated to one particular thread. You can think of thread as a single process, very small process. Or you can think of it in this manner. Let's say I created an object and I say object.m1. I call method m1. Now a section will be dedicated for that method in this stack. So let's see how it's done. Let's get into the internals. Now take a look at this. The execution starts from the main method, and main being a method, a section in the stack will be dedicated for it, for main. Java Virtual Machine uses this section to store all the variables that are local to the main method. In this case, x and y are the local variables that are local to the main method, and these variables will have the scope within that method. Whatever are the variables that have the scope within this method will be residing here. In this case, it's x, just 10, and y, 20. And the interpreter goes line by line. We'll talk about this line pretty soon. When the interpreter comes across with this line, object.m1, we're calling another method. So another section will be dedicated in the stack for method m1. And whatever are the variables that have the scope of m1 will be residing here. In this case, we're sending one parameter x. So we're taking it as parameter p, and the value of that would be 10, because that's what we're sending here. Interpreter enters inside this method and it starts executing lines in it. This is supposed to be m3. When the interpreter comes across with m3, we're calling the method m3. And since this is another method, a section will be dedicated for it to store its local variables, and local variables will be residing here. And once interpreter comes to the last line of method m3, it goes back to method m2 and it will continue with the execution of further instructions in the method m1. Now at this point, since we're done with m3 method, even the memory will be freed and is available for future processing. Once the interpreter comes to the last line of method m1, it will go back to the main method and it will execute the remaining instructions. Once it returns back to main method, even m1 method will get freed, and whatever are the variables that are inside this will be lost as well, because we're done with operations that needs to be performed on those variables. Now once we reach the end of main method, even this memory will get freed. When we have nothing in the stack, that means we're done with the execution of the program. Now let's talk about this particular instruction. We have a heap memory as well, in that we'll store objects, and each and every object will have a location, an address associated with it. This address in here is used to locate that particular object. Let's get into the details. Let me go to a fresh page. Now take a look at this. We have a new keyword used. This particular section in this instruction will create an object in the heap memory. And take a note that we're passing some parameters to the constructor of the maths class 10 and 20, and we're setting the instance variables. And these two variables are instance variables, and they're not local to any method. They are specific to an instance. Hence, this will be stored in here. Maybe A is equal to 10, B equals 20. And in order to identify this object, there will be an address associated with it. Let's assume it's 0101. Now do take a note that the obj in here doesn't hold the object itself. It will hold the reference of that object. Let me explain you what I mean. Let's assume that this is inside a main method. So we'll have a stack created and a section will be dedicated for main method. Now we'll have this obj created in here. And what's the value in it? The value of it would be 0101, which is the address where this particular object is residing. So this is also called as a reference type, because it will have information on where the object is residing. But this obj doesn't hold the object by itself. It will just have some information about where the object is residing. And the scope of this obj is also within this main method. Once this particular section pops out of the stack, then the reference of this object is no longer available. In our stack memory, we store the primitive data types as well as the reference type. You can hear terms like reference type, non-primitive data type, or user-defined data type. They all essentially mean the same. We're talking about a reference variables in which its value would constitute the address where the object is residing. So whatever is residing in the heap will have a global access. That means even though there is nothing left in the stack, we could still have some objects hanging around inside this heap memory, at least for some time, until the garbage collector comes in and cleans them up. We'll talk about garbage collection in a moment. But this is how it works. Let's take a look at another example to bring you more clarity on this. Take a look at this. Okay, let's go line by line. We have created a new object with the keyword new, so that will create an object inside the heap memory with the values 10 and 20, because these are instance variables, and we'll have an address associated with it. In our stack memory, for our main method, by the way, let's assume these instructions are residing inside a main method. There's a section dedicated for main method, and we'll have reference type defined, and it will have the information on the address where this object is residing, which is 0101. And the interpreter comes to line number 2. We have created a new reference type, and we assigned this reference type to it. So we're not actually assigning the object, we're just assigning the address in which the object is residing. So here is how it gets allocated: obj2, and it will have whatever is the value inside this object 1, which is 0101. So essentially obj1 and obj2 are pointing to the same object. We're not creating a duplicate object here. Similarly, on the similar lines, we have object 3, which is holding the value which object 2 is holding, which in turn is holding the value of object. So even we'll have object 3, and that will hold the same value. So all these reference variables are holding information on the location where the object is residing. Hope that makes sense. So now the million-dollar question: why do we need to store objects in heap memory? The reason is simple. Things will get very messy, as well as it will impact the performance dramatically. What do I mean by that? Whatever are the variables residing in the stack memory are predefined types. I mean, we know exactly how much memory they're going to take upfront, right in the beginning when we compile the program. But whereas the object is JVM specific, the size of object is not certain. It can vary from JVM to JVM depending on the vendor. So it's hard to make a guess on how much memory each object would take. There are a lot of factors that come into picture when deciding the memory allocation done for an object. The type of variables, the number of variables, and we also need to consider the space it takes just to maintain the state of this object or to maintain this object itself. So it gets really tricky in here, and let's not get into it. So now that's number one reason. And number two, let's assume that there is no heap memory at all, and that also means there are no reference type. We're directly storing the object in here. Now take a look at this same example. By doing this, we're not actually pointing to single object. We have to create 3 different objects inside this stack, which is pretty consuming. That's a lot of memory, and each object won't consume 4 bytes or 8 bytes. It's a huge chunk of memory, and we're trying to duplicate the same data multiple times. Instead, why not just have reference type and point them to the actual object like we do? So that's reason number 2. Let's take a look at one last reason why you want to store objects in heap memory. Take a look at this example. For the sake of example, let's assume there is no heap memory. So we'll have a stack and a section dedicated for a main method. Again, let's assume this is residing inside the main method. We'll have an object created that will have a huge chunk of information about this object, including these variables, say 10 and 30. Now we're sending this object to this method M1. There will be a new section created for method M1, and its local variable would be the object that we sent. And let's say inside this M1 method, I updated the state of this object. Let's say object.x, I changed this value 10 to 20. Let's assume so. So now inside we'll have an object with the value 20 for x. Once we come out of this method M1, this detail will get popped out of the stack. So that means there is no information related to this method M1. That also means we don't have the details on the updated state. So when we send this object to method M2, a new section will be created, and again the value of x would be 10, not the updated value. This is clearly a problem. We're not getting the updated value, updated state of that object. Hope that makes sense. Now, whereas if the object is residing in the heap, as you can guess, everywhere in all these methods M1, M2, M3, we're actually talking about the same object, and we're all pointing to the same object. If the state is updated by method M1, the rest of the methods will get the updated state. Now let's talk a little bit about garbage collection. We'll get into the details of garbage collection in our future videos, but for now, just a quick explanation on it. When it comes to primitive type or reference type, we're cleaning them up the moment we get out of that particular method. In case of objects, there has to be some way to clean them up. Otherwise, the memory of the heap will get full and we start getting some exceptions or errors like Java heap space out of memory exception. So how does JVM solve this problem? It uses a tool called garbage collection. What that does? It's pretty complicated, but in simple terms, if there are no references available in the stack, that means that particular object is eligible to be cleaned. The garbage collection process happens periodically. There is no specific time for it. It just happens periodically and takes a look at all the objects and see if it has any references left in the stack or elsewhere in the memory. If not, then it will just clean that particular object. And that way the heap memory is maintained, and it will help in not getting the memory to be full. We also have a way to configure the sizes of heap memory and the stack memory. By the way, if the stack is full, we get the stack overflow error, which I'll talk about it later. Now let's go back to our program, and I bet now you'll be able to understand the concept by yourself. Open the file, methods, and constructors. So we have, how many new keywords do you see here in this program? There are 3. That means you can straight away say that we have 3 objects created in the heap memory. In the instruction number 3, we have object 3, which is a reference type, and is actually having the same information that object 1 reference type is holding. That means the address of this particular object. Same with the object 4, it is holding whatever object obj3 reference type is holding. So essentially object 1, object 3, and object 4 are holding the same information about the same object. The reference type object 2 points to a new object altogether, Object 5 is a reference type that holds information about a new object and whose state is set based on the object 1. So that this should be 10 and 40. Hope that makes sense. See you in my next video. In this video, I'm going to talk about this keyword. Take a look at this program. We just simply created an object, an instance of a class, maths, and I have sent a couple of values here, 10 and 20, and we're trying to find the addition of those two values. Now I'm going to make a small change here. I'm going to change D to X and K to Y. So what does this mean? The name of both local variables and instance variables are both same. Now if I run this program, what is the result that you're expecting? Would get 0. I'll tell you why. Let's run the program. The reason is the compiler could not figure out if this X is a local variable that was sent as a parameter here, or is it an instance variable. Hence it just didn't do anything. By default, the value of int would be 0. So the sum of 0 and 0 would be 0. Now how do we fix this? We use the keyword called this. But before that, there's one key thing to understand. Whenever we call a constructor or a method, we're also sending one parameter, which we don't see it here. That parameter is nothing but the current object. We're just sending the reference variable to that method. And we know that reference variable holds the address where the actual object is residing. And when we do so, we can play anything with that. We can do anything with that object. The keyword that we need to use is this, which means the current object. Essentially, this is same as obj and obj. Certainly, we don't use the word obj. That's because we can have more than one object. For example, like Control C and Control V, I could name this as object 1, and we cannot change the name here to object 1 because it might cause problem with this statement. So we're just simply going to use a generic word called this. This will just implicitly assume the current object. With this statement, this will be replaced with obj during compile time, and with this statement, this will be replaced with object obj1. Now this will solve our problem. Compiler is certain that this is an instance variable and the X in here is a local variable that is sent as parameter. Let's try to run the program. Great, 30. Now as I mentioned, even when we're calling a method, the current object will be sent. Let me add another method here. I say void set values int X and int Y, and I'm just going to simply copy paste this code in here. I do Alt Shift F to give proper indentation. Now from here, using one of these objects, I'm going to call set values. I'm going to give 50 and 50. Now what is the result that you're expecting? It would be 100. That's because we have set the values to 10 and 20 initially, but those values are actually overridden when we call this method set values. So we got an updated value here for both X and Y. Now let me just get rid of this statement, the keyword this, and try to run the program. What is the result that you're expecting? You think it's 0, or would it be 50, or would it be 100? You'll be surprised. It would be 30. That's because of the same reason. Compiler is confused and is not able to figure out if this x in here is a local variable or an instance variable. Hence, it just didn't do any changes at all. The last updated values were 10 and 20, and hence the result is 30. Hope that makes sense. See you in my next video. I have said this a million times by now, that objects can literally be used just as any other data type, any other primitive data type like int, float, etc. This is one such example which explains the same. I'm going to demonstrate you how to send an object as a parameter to a method, and also how to return an object from a method. The same thing is applicable even for constructors. Now what I'm going to do is, I have two objects created. One is derived from the maths class and the other one is from the car class. Inside this car class, I'm going to write a new method which will take the input, which will have the parameter of an object, and the object that I'm going to send is of the maths class. So let's see how it goes. I'm going to get inside this void. I'm going to give this method a name, object param example maths object, and I can do anything with that object in here. Maths object dot x equals 100. I'm going to leave the y value. Now take a note of this. What is the data type here? It's maths. It's a user defined data type, or you can call it as a non-primitive data type, or even you can call it as a reference type. And obviously we need to call that method from here using the car object. Let's save the file. Now we have already set some values while creating the object itself. The 7 is for x and 10 is for y. But with this statement, we have reset the value of x to 100. If I run this program, okay, before that let's write down another line. It's math addition. Now this will give us the result of the sum of x and y. Let's run the program. Great, the result is as expected. Now let's see how we can return an object from a method. Again, let's introduce one more method. This time the return type is of maths object instead of void. Example. And in here I'm just simply going to return a new object altogether. That's 70 and 848, let's say, or for simplicity let's make it 30, so that the sum of these two numbers would be 100. This will create a new object, alright, and the values of x and y will be set to 70 and 30. We need to collect whatever is being returned from this method. Let's do that. Let's comment out these two lines. again car object dot object return example. Now we could either write maths new object equals this and new object dot addition blah 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 system dot out dot print ln. You could either write it this way or simply cut off all this stuff and simply you can just do system dot out dot print ln. You can simply just use the dot operator right here. Let's save the file and run the program. The result should be 100. It is. Great. By the way, we haven't talked about this dot operator, but by now I'm sure you must have understood what it is doing. It will let us access the instance members, be it instance variables or instance methods. Also, we can assign some values. For example, in here, using the dot operator, we got control of that particular field and we assigned a value. Alright, see you in my next video. We're going to talk about pass by value and pass by reference. This is one of the most confusing terms you often hear. Especially if you have a background of C language, then you're the one to get confused on that. Let me help you get clarity on it. See you in my next video. I have said this a million times by now that objects can literally be used just as any other data type, any other primitive data type like int, float, etc. This is one such example which explains the same. I'm going to demonstrate you how to send an object as a parameter to a method and also how to return an object from a method. The same thing is applicable even for constructors. Now what I'm going to do is I have two objects created. One is derived from the maths class and the other one is from the car class. Inside this car class I'm going to write a new method which will take the input, which will have the parameter of an object, and the object that I'm going to send is of the maths class. So let's see how it goes. I'm going to get inside this void. I'm going to give this method a name, object param example maths object, and I can do anything with that object in here. Maths object dot x equals 100. I'm going to leave the y value. Now take a note of this. What is the data type here? It's maths. It's a user defined data type, or you can call it as a non-primitive data type, or even you can call it as a reference type. And obviously we need to call that method from here using the car object. Let's save the file. Now we have already set some values while creating the object itself. The 7 is for x and 10 is for y. But with this statement we have reset the value of x to 100. If I run this program, okay, before that let's write down another line. It's math addition. Now this will give us the result of the sum of x and y. Let's run the program. Great, the result is as expected. Now let's see how we can return an object from a method. Again, let's introduce one more method. This time the return type is of maths object instead of void. Example. And in here I'm just simply going to return a new object altogether. It's 70 and 848, let's say, or for simplicity let's make it 30, so that the sum of these two numbers would be 100. This will create a new object, alright, and the values of x and y will be set to 70 and 30. We need to collect whatever is being returned from this method. Let's do that. Let's comment out these two lines. Again, car object dot object return example. Now we could either write maths new object equals this and new object dot addition blah 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 system dot out dot print ln. You could either write it this way or simply cut off all this stuff and simply you can just do system dot out dot print ln. You can simply just use the dot operator right here. Let's save the file and run the program. The result should be 100. It is. Great. By the way, we haven't talked about this dot operator, but by now I'm sure you must have understood what it is doing. It will let us access the instance members, be it instance variables or instance methods. Also, we can assign some values. For example, in here, using the dot operator, we got control of that particular field and we assigned a value. Alright, see you in my next video. We're going to talk about pass by value and pass by reference. This is one of the most confusing terms you often hear. Especially if you have a background of C language, then you're the one to get confused on that. Let me help you get clarity on it. See you in my next video. In this video, I'm going to talk about pass by value and pass by reference. Take a look at this program. We have a main method, and inside the main method we have initialized a variable x, and we are sending that as a parameter to a method which is in another class. Here is how it works. We'll have a stack memory in that a block will be allocated to main. In that we'll have the value x, which is 10. When we call a method from inside the main, we're going to stack up another block for that method, and note that we're sending this parameter x. If we are talking about pass by reference, then we're actually sending this value to this block. In Java, it is not supported. In Java, there is nothing called pass by reference. We only have pass by value, wherein we'll send a copy of that variable. So when we do this, we're actually making a clone or a copy of this field and we're sending it to this method. So we'll have another variable. The scope of this variable is within this method, and once this method exits, then this block will get freed. If we are using pass by reference, then the value of x would be 20. That's because we are updating the value here. But since Java is pass by value, the value of x would still remain as 10, not 20. Now we understood what is pass by value and pass by reference. Let's take a look at our code. I have jotted down 3 different scenarios. In our scenario 1, we have a variable x and we're sending that as a parameter. The initial value of x is 10, and after we send that value or the variable to this method example 1, we're updating the value of x to 100. The line next to it is we're just printing the value of x. Since Java is pass by value, we're not actually sending this x. We're actually making a clone or a copy, and then we're sending the copy to this method. So in essence, nothing will get updated, at least in main method. The value 100 is applicable all the operations that you do in this example 1 method, and once we come out of it, the value would still retain to 10. So the output of this statement would be 10. The confusion arises, however, when we send an object. Objects are references, and this might sound a little confusing because when you're sending a reference, that might sound as pass by reference, which is wrong. We're still sending the reference type as a value. We're not actually sending this math object, we're actually sending a copy of the reference object. A copy of the reference. I mean, this math object will only constitute the address wherever this object is residing in the heap memory. And in example 2 method, we're essentially a copy of that address. And when we do so, this new variable in here will have that address assigned. And the scope of this variable is actually within the block of this. I think this can be better explained in the whiteboard. Let me take you there. Again, let's assume we have a stack memory and heap memory. Since we have created 2 new objects, we'll have an object of examples, we'll have another object for maths with some addresses. In our main method stack block, we'll have these reference variables obj and maths obj. We're good so far. Now in here we're calling a method, and whenever we call a method, we'll have a new block created in the stack for that method. For example 2. And when we're sending this object, we're not actually sending this reference type. We're actually sending a copy of it. So a copy of this is made and is made available here as well. Maths object. But take a note of this. Both these 2 reference variables are actually pointing to the same object. Hence, this statement in here, object.x, if we make it to 100, the change will reflect in here as well. When we do system.out.println mathsObject.addition, then it's going to find the sum of 100 and 5, because the value x, which was 5, is now updated to 100. Now let's go back to our code. We have a third scenario here. I'm essentially doing the same thing what we're doing here, but if you go inside that method example 3, I'm creating a new maths object and assigning that object to this new reference variable, and then I'm trying to update the value of x in here. I have jotted the same code in our whiteboard as well, and let me explain you over there. Once again, we'll have a stack memory and heap memory with 2 objects. One is of examples, one is of maths. When the interpreter comes across with this statement, we'll have another block for that method, example 3. And by the way, main block will have object and maths object. Since we send this object as a parameter to this method, we're going to have another copy of this reference variable. Great. So we've reached till this point. Now when this statement is interpreted, we'll create a new object altogether. This is a third object, and the reference name that we used is new object here, and we assigned this reference to obj. So obj was actually pointing to this object earlier, but with this line now it's pointing to whatever this reference variable is pointing to. Now this is pointing to this object, hence even this would start pointing to this object. This is no longer pointed to actual object. So whatever updates I do with object.x equals to 20 or object.y equals 30, it will be updated in this particular object, but not the original one. Based on your understanding, okay, let's go back to our code. Now try to look at the code and try to guess the output of this program. The output of this would be 10. The output of this would be 105. And the output of this would still be 105. There won't be any difference. Let's run the program. There you go. In this video, I'm going to talk about comments in Java. Comments are there for the convenience of the programmer. They just describe your code. It's the responsibility of the individual programmer to comment on his or her code. That being said, it's not mandatory. It's just a good practice. In fact, compilers will simply ignore all the comments while compiling the code. All the gray text in here will be ignored by the compiler. These are all comments that are meant for developers. So you shouldn't be the only person who understands your code. You also need to think about the other programmers who will come and take a look at your code at a later point of time. Even they should be able to understand. And one way to convey what your code is doing is through comments. Now there are two types of comments. One is for the programmers who is going to take a look at your code and possibly make modifications. And the other is for the programmers who will not be able to take a look at your code but can use your code. Let me explain you what I mean. I'm initializing a couple of variables in here, and I've mentioned the same thing as a comment in here. X and Y are variables and are initialized here. To make a single line comment, you need to use double slash like this. However, if your comment is spanned across multiple lines like this, then you need to enclose them within /* and */. Now these two comments that I've shown you are for the programmers who is going to take a look at your source code and make modifications. By the way, I have just commented on these initializing the variables. In real world, we usually don't comment on such simple lines. We would usually comment on methods, constructors, and objects that usually a programmer is not aware of. Okay, moving on. Now the second type of comment is documentation comment. This is a little tricky. Let's say I wanted everybody to use my class, use the functionality I'm providing. For example, I wanted somebody else to make use of the method I write. But at the same time, I don't want anybody to make changes to my code or copy my code. How do I handle this? I'll simply compile this code. I get a .class file. I'll share the .class file to everybody, and they'll be able to create an object of this class and then call this method whatever. But since they cannot take a look at my source code, how would they see the comments inside it? They cannot. Compiled version of the Java file will not have comments anyways. How to solve the problem? How do we tell the programmer what we're doing in the source code? Is through documentation comments. For documentation comment, they start with /" and ends with a // with a star in each line. And there is a specific format that you need to follow when it comes to documentation comment. We can also use the tags like this. All the tags will start with @symbol. You will see in a minute why we have tags. In order to generate documentation for this class file, we need to use a tool called Java Doc. It comes with the JDK. You don't have to install it separately. Just as Java-C is a compiler, Java Doc is a tool that will generate the documentation of your program based on the documentation comments you provide. That tool will generate a HTML document which you can share it to anybody that you wish. So let's try to use that tool. You need to open a command processor and navigate to any directory that you wish. This would be the directory where our documentation files will be generated by the tool. And all you have to do is use this tool Java Doc and then give the complete path of the Java file. To get the complete path, you can simply go to properties of that file and you find the complete path in here. You can copy that and paste that over the command processor. Let's go back. Let's get inside this folder and make sure nothing is there in that directory or the folder. By the way, I use mix of terms like directory or the folder. They both refer to same because usually we programmers use Linux system and the folder in Windows is directory in Linux. Okay, moving on, let's run this command. Let's go to that directory, open this HTML file. If you're not aware of HTML, that's fine. We're going to talk about it. We're going to talk about it in our future videos. Let's click this Java comments. We have a description of that class. This program will demonstrate the use of Java comments. List of constructors that this class is holding. Currently it's the default one. And since we didn't provide any documentation comments for this constructor, it's showing nothing. But we do have documentation comments for method, addition, and then the signature of that method, a quick summary of that method. Using annotations, we have described the parameters. Now you can observe why we have annotation. It will just give a proper separate section dedicated for that parameters. And the returns annotation, here's the description for it. Third-party programmer who's going to use your class file to use the functionality can take a look at this HTML document and get a sense on what these methods or constructors are doing. Let's go back. And do take a note that we can also use tags in here. These are HTML tags. Again, you might not be aware of HTML. That's okay, we're going to talk about it. So that's it. Oh, but wait a minute. Since the documentation comments is not of utmost importance, I'm not going to go deep into this because I feel it's not worth it, at least at this point of time. When you enter the mainstream, you'll be forced to do documentation comments anyway, so it's not really worth spending time going deep into this. We have a mountain of other topics to be covered and understand, so let's not waste time in here. But just in case, although I'm not recommending, if you wanted to go through all the description of Java Doc and go through and understand what are all the tags that we have, then you can get inside this link. Here you can see the introduction of it. You also have a tool, document checking tool. This will check to see if your documentation comment is in proper format or not. It's really important that you give proper formatting, or you need to follow certain guidelines while providing the doc comments. Otherwise you will see your text not getting populated in here. So it's always good to use this tool, because in mainstream you'll have a book of documentation in each source file. So it's always better that you run your file through this tool and then see if there are any formatting errors. It takes a lot of time to manually verify the documentation comments and see and guess what's going wrong. So this tool will definitely come in very handy for it. You can also go through all this description and all these tags in here. We've already used this param tag, the return return tag, etc. Alright, see you in my next video.
Let's talk about text blocks in Java. Imagine that I have this HTML code which I wanted to make it part of a string. Or let's say that I wanted to store this as part of a string variable. Now I cannot just copy this code as it is and store it as it is inside a string literal. That's because this code right here has certain characters which might be conflicting with Java existing characters. For example, this double quotation could be used to encapsulate a string, and so we might confuse the Java compiler as to whether do we mean to say that this is double quotation or are we using to encapsulate a string. So in order to avoid that confusion and to let the Java compiler know that we are actually intended to use this as a double quotation, you have to escape it so the compiler won't get confused. In addition to that, you also need to include a new line character at the end of each and every line to represent a new line. Now, this is just 5 lines of code. Imagine that we have 100 lines of code, for instance. It makes it really hard for a developer to find out all those characters which might be conflicting with existing Java characters, escape them, and also include all these extra characters like new line character, for instance, so on and so forth. Let me show you what I mean. So I'm going to copy this code as it is. What I have here is I've just defined a string variable, and that's what I'm trying to print in next line. Now let me paste the code inside these double quotations. Now Eclipse has done the job of escaping these double quotations as well as including all those additional characters to ultimately represent the string in this exact format, which is great, but this makes the code less readable because not only does this have the HTML code, but also all these weird characters which we don't like to see inside our string. Let me run the program, and as expected we're going to see the code, but at the cost of readability. So in order to solve this problem, we have text blocks which were introduced in Java 13, and the way you define a text block is simply by using triple double quotations to start with, and you're going to end with triple double quotations, inside which you can include any string that you want and not bothered about escaping the characters or including new line characters whatsoever. So I can paste the code as it is, and what you see is what you get in the output. I'm going to save the file and run the program once again, and you're going to see exact same code, and even the indentation is maintained as it is. In case if you wanted to use triple double quotations inside the code, it is then you have to escape it in order to not confuse the compiler. So this might create confusion to the compiler. I'm going to escape it by including this slash in front of it. So basically we have to escape one of the double quotations, and it would be treated as bunch of characters and not as a text block or whatsoever. So this is a really cool feature which will come in handy, especially if you wanted to store some kind of a code like JSON or HTML, which might have certain characters that might conflict with Java existing characters. Hope it makes sense.
In this video, I'm going to talk about the static keyword. And for this purpose, I have created this class called car with 3 variables: wheel count, gear count, and the height of the car. We have a constructor that will initialize these variables. And we also have a display method that will just simply display these variables that the current object holds. In our main method, we have instantiated 4 objects of class car, and we're just invoking the method display. Let's try to run this program. Cool. Let's go to whiteboard and see how the memory management is done for this program. And do keep in note that we have 4 different objects created. So in our heap, we'll have 4 different objects created of class car. Now if you have noticed, there is one variable in this class whose value is common for all the objects, that is number of wheels available. For any car, the number of wheels available would always be 4. At least for the sake of explanation, let's assume so. When we're creating 4 different objects, we're also creating 4 different memory locations for the variable number of wheels. So this would result in creation of 16 bytes of memory, since integer takes 4 bytes of memory. This is not the efficient way of memory management. So what we're going to do is we're going to mark this variable as static. What that would result in is this variable will no longer be associated with the object. Instead, it will be associated with a class. And this variable will be moved to a new memory location called permanent generation. And whatever resides in the permanent generation space is actually associated with a class, not with an object. And now, instead of creating 16 bytes of memory, we're just creating 4 bytes of memory. And this memory location will be shared across all the objects. All the objects will be able to access this memory location and be able to get the value or even change the value. Now let's go back to our program and see how it's done programmatically. So every time we're creating a new object, we're also setting the value of number of wheels available. Now we can get rid of this. Of course, we'll have errors here because in our constructor, we're expecting a parameter, number of wheels available. Let's get rid of that. Let's make the wheel count static. Everything looks good. Let's try to run the program. Good, we got the same result. Now this particular program doesn't necessarily demonstrate the use of static keyword. Let me give another example. Let's say we wanted to count number of objects created for a particular class. For that, let me just get rid of this, or maybe I'll just comment this out with /* and */. We'll talk about comments in future videos. And what I'm going to do here is I'm going to create a new variable which is static int count equals 0. And in our constructor, every time we invoke the constructor, we're just going to increment the count. So every time we create an object, we're also invoking its constructor, and we're just going to increment this static counter. Now in order to display this, we can just access this variable in here count without using the object of this class. Like I said, when I mark a variable or a method as static, it's no longer associated with an object, it's associated with a class. So we can access this particular field even without creating an object. Let's see how it's done. System.out.println car, which is the name of the class, and the auto suggestion shows the count. Now let's try to run the program. For which is expected. Let's not make this a class variable, let's make this an instance variable. And now let's try to run the program and see the output. Since this variable is no longer associated with the class, we cannot access with the class name, we can access with the object name, and whichever object you're going to use, we get its associated value. So I don't see any purpose in demonstrating this. Let's get rid of this and we're just going to rename this back to static. Save the file. In the similar fashion, we can have static methods as well. And just as static variables, static methods are linked to a class, not with an object. Let me just demonstrate it. I'm going to create a new method here, which is static void static method, and I'm just going to do system.out.println count, and in here we can get rid of this statement. Instead of saying car.count, I'm just going to call that method car.static method. Let's save the file and run the program. There's one key point to understand here. This static method in here is not aware of the objects that are created with that class. Essentially what that means is, when we're calling a method using an object, we send the current object as a parameter implicitly. But that's not the case with the static method, because we don't have an object in first place. We're just simply using the class name. And with that being said, in our static method, we cannot access any instance variables. We can access only static methods or static variables. The count in here is static. If we get rid of this statement in here, we're going to get an error, and that's pretty expected. So from static method, we can only call other static methods or static variables. Now, can you try to figure out why main method is static? Pause the video and try to guess. Okay, let's assume that main is not a static method. Then somebody has to take care of creating an object of this class, and then we invoke this method main. Who is creating it? Nobody. The JVM way of solving this problem is, it will expect us to write a method with exact same name, main, including the case, and it has to be static, so that JVM can easily access this method using the class itself without creating an object. Because when we create an object, it's going to result in creation of memory location as well, which is not required. So that makes sense, right? Also, in fact, we've been using this static method throughout our course so far. Let me show you what I mean. The system.out.println. What is this? System is a class in which we have a static member out, which in itself is a reference variable, and out.println is nothing but we're just calling the println method of object out. Hope that makes sense. Now, the static variable doesn't necessarily have to be a primitive type. It can also be a reference type as well. There is one risk associated with static variable. Let me show you what I mean. Since this static variable is accessible across entire application, from anywhere in the program we can change the value, and that will impact all the objects across the application, which is not intended. For example, I don't want anybody to change the value of number of wheels available, because I know it would always be 4. So how do we handle this? We can handle this by using the keyword called final. Let's go back to our program. So instead of just calling it static int wheel count, I'm going to call it final static int wheel count. Now from the display method, I want to change the value of wheel count. It just won't allow me to do that. Now see the error. Cannot assign a value to final variable wheel count. Great, I guess we're good.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.